Hey everyone, today we're going to put on our detective hats and solve a really cool but actually kind of simple chemical mystery.
So here's the mystery we're tackling. You've probably seen this before, right? Maybe in science class, maybe on YouTube. You take two liquids that are totally clear, pour them together, and poof, it instantly gets cloudy, almost like milk. But then you do the same thing with two different clear liquids, and nothing. It just stays clear. So what gives? What's going on here? Let's dive in and find out.
All right, to get to the bottom of this, we're going to look at two specific examples, two reactions that on the surface look pretty much the same.
Okay, here are our two suspects. On one side, we've got reaction A, calcium hydroxide mixed with carbon dioxide, and on the other, reaction B, sodium hydroxide with hydrochloric acid. Now, the key thing here is that in both cases, we're starting with clear solutions. So, why the totally different endings?
First up, let's zoom in on our first case file. We're putting reaction A under the microscope to see what's really happening.
It's super simple, really. Step 1, you've got your two clear solutions. Step 2, you mix them. And then step 3, wow, almost instantly, this cloudy white solid just appears out of nowhere. It's a pretty dramatic transformation, going from perfectly clear to this milky solid.
You know, this cloudy stuff actually has a name. It's called a precipitate. That's the fancy science term for any solid that just pops into existence in a liquid during a chemical reaction. Okay, so we've got a name for it, but we still don't know what it's made of.
And the culprit is calcium carbonate. This might sound familiar because it's the main ingredient in stuff like chalk, limestone, even marble. So yeah, this reaction is literally making chalk right in the beaker. How cool is that?
All right, so case 1 is on the books. Now, let's switch gears and open up our second case file. Reaction B. This is the one where things, well, didn't get cloudy.
So the setup is exactly the same. You grab your two clear solutions, you pour them together, and absolutely nothing happens. The liquid just stays totally clear. No cloudiness, no solid, no drama at all.
The key observation here is simple, but it's super important. There is no precipitate. And that leads us to the big question, why not? What was so different this time?
Well, hold on, a reaction definitely happened. A brand new substance was formed. In this case, the product is sodium chloride. And if you're thinking, hey, that sounds familiar, you're right. It's just plain old table salt.
Okay, let's review the evidence. We've got one reaction that makes a cloudy solid and another that just makes, well, salt water. It's finally time for the big reveal. The reason for this huge difference all boils down to one key idea: the solubility secret.
And it all hinges on this concept called solubility. It's really just a word that asks, can this stuff dissolve in water? See, if a substance is insoluble, meaning it can't dissolve, it has nowhere to go. It's forced to show up as a solid, that precipitate we saw. But if a substance is soluble, like our salt, it just dissolves completely and kind of disappears, staying hidden in the water.
So let's just lay it all out side by side. In reaction A, we made calcium carbonate. That stuff is insoluble, so we get a precipitate. Bam! In reaction B, we made sodium chloride. That's super soluble, so no precipitate. The whole result, clear versus cloudy, just depends on this one property of whatever new stuff gets made.
So now that we've cracked the solubility secret, it's time to close this case for good and deliver the final verdict.
And here it is, plain and simple. Reaction A got cloudy because it made an insoluble solid, calcium carbonate. It literally can't dissolve, so it has to show itself. Meanwhile, reaction B stayed clear because its product, sodium chloride, is soluble. It just hangs out dissolved in the water, totally invisible. And that's it. Case closed.
And that pretty much wraps it up. It's just a great reminder that so much of what we see or, don't see is all controlled by these invisible rules, these properties like solubility. It really makes you think, right? What other hidden properties are out there, quietly shaping the world we experience every single day? Something to chew on. Thanks for digging into this with me.